Hi, I'm Charles Wasson, author of Systems Engineering, Analysis, Design, and Development, Concepts, Principles, and Practices. I'm delighted that you've chosen to take this opportunity to learn more about this exciting 21st century systems engineering textbook. Are you aware that most so-called systems engineering today is not system engineering? Actually, it's about a concept called systems management, known today as project management and configuration management. Systems management was a management approach instituted in the early 1950s to manage high failure rates in large, complex military system development projects. It focuses on managing the development of systems from an acquirer's perspective, namely overseeing the systems engineering activities of system developers. Yet the title Systems Engineering, which focuses on the engineering of systems, continues to be used out of context by industry, government, textbook authors, and professional organizations. As a result, the core technical engineering aspects of systems engineering have been largely ignored over the past 65 plus years, resulting in a growing technical competency void. Systems engineering, analysis, design, and development was written to correct this void in genuine systems engineering. To better understand the systems engineering technical competency void, let's frame its context educationally. Traditional engineering disciplines are based on a taxonomical infrastructure of concepts, laws, theorems, and principles and practices traceable to a scientific domain or phenomenon. In contrast, systems management only exists in the form of standards, handbooks, processes, and certifications for managing the development of systems. As a result, the systems management paradigm has been unwittingly promulgated via textbooks, courses, and vendor training as, quote, systems engineering. In the late 1980s, industry and government recognized the need for just-in-time, team-based decision-making throughout a system's lifecycle. That is, the timely orchestration of expertise or knowledge, skills, and abilities, that is, KSAs, of engineering disciplines at the right time. Although the recognition was a step in the right direction and improved somewhat, systems management's shallow depth violated a cardinal rule of systems engineering: understand a team's operating environment. Anecdotal evidence based on the author's experience, yours may be different, suggests that most engineers spend, on average, from 50% to 75% of their total career hours making systems decisions for which they have no formal education. When they participate in team-based decision-making environments, they bring different viewpoints and mental frames of reference, different semantics and definitions, different problem-solving and solution development methods, different processes, and different or incompatible tools, and so forth. Here's the irony. Systems management claims to be the interdisciplinary systems engineering integrator of engineering disciplines on technical projects. The reality is there's an educational disconnect between the knowledge, skills, and abilities, KSAs, of traditional engineering disciplines and the KSAs of systems management on technical projects. Is there any wonder why projects continue to exhibit technical, cost, and schedule performance issues that systems engineering, that is, systems management, claims to correct? To solve the systems engineering problem, systems engineering analysis, design, and development was written to backfill the systems engineering technical competency void based on 21st century systems engineering advancements. This text is not about backfilling the void with outdated 1980s systems engineering paradigms that dominate industry, government, textbook authors, education, professional, and standards organizations. In fact, this text is the most comprehensive compilation and codification of genuine systems engineering concepts, principles, and practices published to date. This textbook shifts the systems management paradigm to its proper place as a component within the systems engineering discipline. Now, educators and professionals have a textbook for teaching and performing the concepts of interdisciplinary systems engineering integration. Interdisciplinary teams in industry and government across all engineering disciplines share a common set of semantics and definitions, a mental frame of reference, convergent problem solving and solution development methodologies, processes and methods, analytical tools, and so forth. This text provides the requisite KSAs, especially in today's traditional model-based systems engineering or MBSE environments. These KSAs provide the foundation for MBSE that goes far beyond the act of incoherent connecting boxes and lines and entering sets of data into a searchable MBSE relational database tool. Given this backdrop, let's explore a few of the text's key instructional features. In support of the system lifecycle, the text consists of 34 total chapters partitioned into an introduction and 3 parts traceable to each other. Part 1, titled Systems Engineering and Analysis Concepts, provides the foundational concepts, that is, the whats and whys. Part 2, titled System Design and Development Practices, builds on Part 1 and addresses the how-tos, when-tos, and where-tos. Part 3, titled Analytical Decision Support Practices, provides the tools for decision-making in Parts 1 and 2. This textbook was developed to be inspiring, easy to read and understand for its readers, and features 288 full-color graphics to visually complement and support the text descriptions. Another key feature that educators, students, and professionals will find very useful in the textbook are its icon-based landmarks. In fact, each text landmark is uniquely identifiable, indexed based on the chapter number and sequence within the chapter, and well annotated to support the text descriptions. You will find 365 principles, 148 author's notes, 231 examples, 31 mini case studies, and over 690 definitions. Complementing the color graphics, you will also find 60 tables that provide tabular insights supporting the text descriptions. There is also a bibliographical listing that includes 345 thoroughly researched and documented references. The text includes 2 levels of chapter-based exercises. Level 1 exercises at the end of each chapter are intended for upper undergraduate level and graduate level classes. Level 2 exercises, available separately, are intended for graduate level classes and focus on real-world problem exercises. 3 appendices are provided to supplement all 34 chapters in the text. Appendix A provides a quick lookup of key acronyms and definitions. Appendix B provides linkages to the NCOSE Systems Engineering Handbook for those studying for the Certified Systems Engineering Professional or CSEP exam. Appendix C provides a quick overview of key SysML constructs used in the text graphics. Lastly, the index consists of a comprehensive 25-page listing of key terms that include bold-faced page numbers for source definitions and regular font page range locations of key discussions. As a supplement to the text, John Wiley established a companion website instructors will find very useful. In fact, instructors can browse by resource such as an instructor's reference guide, level 2 chapter exercises, a bibliography, a table of contents, and a case study articles links document. In summary, if you are an instructor who seeks to prepare competent upper undergraduate and graduate level students who are highly recruited by industry and government, or you are an industry or government professional, manager, or executive and seek to restore systems engineering discipline and technical competency to your projects, this is the text you need. In fact, this text has become a standard desk reference for professionals worldwide. To learn more about this outstanding textbook, visit the textbook's webpage at www.wiley.com. Educators can learn how to obtain a technical evaluation copy by contacting your local Wiley sales representative today or via the textbook's webpage. In closing, I hope you find this introductory overview helpful and encourage you to explore the text. Thanks for watching.